Imagine a train that never needs to stop for fuel or charging. Is it even possible? Today, we're witnessing an unprecedented event on Africa's revolutionary RF train, an infinite range test that could redefine electric travel forever. Forget everything you thought you knew about electric trains. In 2025, Africa is unveiling a technological marvel, the RF train, promising infinite range. We're putting that bold claim to the ultimate test right now. Can this groundbreaking innovation truly push the boundaries of what's possible and usher in a new era of sustainable travel? What if the trains could travel across continents without ever needing to refuel? What's the revolutionary promise of Africa's RF train? Join us as we witness an extraordinary test of its infinite range capabilities, a moment that could fundamentally transform global transportation and usher in an era of truly sustainable mobility. This is the RF revolution, and it begins here. For more than a century, trains have been the backbone of trade, travel, and connectivity. From the age of coal-powered steam engines to modern electric trains, the mission has always been the same: moving people and goods faster, cheaper, and more reliably. But throughout history, one limitation has persisted: range. Steam trains needed coal and water stops. Diesel trains required fuel depots. Electric trains, while cleaner, depended on either constant overhead wires or massive onboard batteries that eventually run out. The world has dreamed of a train that could travel indefinitely, unshackled from fuel stations and charging hubs. That dream is now being tested in Africa. At the heart of this test lies a radical technology: RF energy transfer. Instead of relying on bulky batteries or a tangle of wires above the tracks, the RF train uses invisible radio frequency energy to power itself continuously as it moves. Imagine a railway that becomes its own wireless charging pad, delivering power to the train in real time, without cables, plugs, or pauses. This isn't science fiction. It's happening here, right now, on African soil. The test track stretches for hundreds of kilometers, designed specifically to showcase the technology's endurance. At first glance, the RF train looks like a sleek, modern electric train: aerodynamic, efficient, quiet. But underneath its body lies a unique receiver system tuned to absorb RF energy broadcast from coils and transmitters embedded along the tracks. Think of it like wireless charging for your phone, except scaled up thousands of times, powerful enough to move an entire train at full speed. Instead of depleting a finite battery, the train is fed a constant stream of power as long as it stays on the track. The result? In theory, unlimited range. The moment the train began rolling out of the station, the atmosphere was electric, no pun intended. Onboard screens displayed real-time data, speed, energy intake, and distance traveled. As the kilometers ticked by, the train showed no signs of slowing, no signs of draining, no signs of strain. It glided along the tracks as if connected to an endless supply of energy. Engineers inside the control cabin watched closely. Some had been working on this project for nearly a decade. They knew that this test wasn't just about proving a technology, it was about proving a future. Every sensor, every monitor, every circuit was under scrutiny. Would the RF system maintain perfect resonance between track and train? Would the energy transfer remain stable at high speeds? Could the train truly keep going indefinitely? As the hours passed, the data remained consistent. The RF train maintained cruising speed without a single dip in performance. Unlike battery trains, which gradually weaken as their charge runs low, the RF system delivered constant, unwavering power. Passengers on board barely noticed a miracle happening beneath them. The ride was smooth, quiet, and unbroken. No stops, no interruptions. For the first time in rail history, energy felt infinite. To understand why this matters, we have to step back. Conventional electric trains require expensive infrastructure like overhead wires, which demand continuous maintenance, or enormous battery packs that are costly, heavy, and environmentally challenging to produce. But the RF system bypasses both. By embedding transmitters directly into the railway, Africa has created a track that doubles as an energy network. This means no battery swapping, no charging downtime, and no fossil fuel dependency. The train never has to stop unless people need to get off. This is transportation redefined. During the test, engineers explained how the RF system works. Each segment of track is embedded with coils powered by renewable energy sources such as solar and wind farms nearby. These coils emit RF energy that is captured by receivers under the train. The energy is instantly converted into electricity that powers the motors. And because it's wireless, there are no moving parts, no overhead cables, and no wear and tear from physical connectors. This reduces maintenance costs and increases efficiency. It's like laying down invisible rivers of power across the land. Critics initially doubted the concept. They asked, would RF be powerful enough? Would interference disrupt performance? Would the system be safe for passengers and the environment? The engineers answered with data. The frequencies are tightly regulated, safe, and shielded. The power transfer is precise and efficient with minimal loss. And today's test proves it works not just in theory, but in practice. The most astonishing part of this journey isn't just that the train is still running. It's that it could keep running forever. Unlike fuel tanks that empty or batteries that die, the RF system is only limited by the availability of renewable energy feeding into the grid. If the sun shines and the wind blows, the train never stops. Imagine freight trains carrying goods from one end of Africa to the other without a single refueling station. Imagine passenger trains crossing borders, running day and night, seamlessly powered by an invisible grid. The economic implications are massive. Transportation costs could plummet. Trade routes could expand. Remote communities could be connected like never before. And all of it without burning a drop of fossil fuel. Environmentally, the benefits are staggering. Rail transport is already one of the cleanest ways to move people and cargo. But by removing diesel engines and eliminating batteries, the RF train takes sustainability to a whole new level. No emissions, no toxic battery waste, no energy shortages, just a continuous flow of clean power. During the live test, journalists and scientists aboard asked tough questions. How scalable is this? Could entire countries realistically lay down RF-powered tracks? The project leads were honest. Yes, there are challenges. Building the infrastructure requires significant investment. The RF systems must be carefully tuned to avoid inefficiencies. And widespread deployment will take time. But they stressed one key point: the foundation works. Today's test proves the concept is not just a dream. It's real, it's reliable, and it's ready to expand. As the journey continued, milestones were celebrated. 100 kilometers, 200 kilometers, 300 kilometers. The train didn't slow down. Its range wasn't measured in kilometers anymore. It was measured in infinity. For the passengers on board, the experience felt surreal. Looking out the windows, landscapes changed, but the ride never paused. No stations for refueling, no interruptions for charging. Just a seamless journey powered by invisible energy. This test has ignited conversations worldwide. Could Europe adopt RF trains to connect its nations more efficiently? Could Asia deploy them for high-speed rail over vast distances? Could North America replace its aging diesel fleet with infinite range alternatives? The possibilities are endless, and Africa is leading the charge. For centuries, Africa was seen as a consumer of technologies developed elsewhere. But with the RF train, Africa is not just catching up, it's setting the pace. This invention positions the continent as a global pioneer in sustainable transport. It's not just about technology, it's about identity, pride, and leadership. The symbolism is powerful. A continent long underestimated is now unveiling a train that could change the world. And the world is paying attention. As the sun set over the horizon, the train was still running strong. The test data continued to stream in, flawless and steady. No dips, no failures, just proof of concept on the grandest scale imaginable. When engineers finally decided to end the test, it wasn't because the train had to stop. It was because they had proven enough. The train could have kept going forever. And that realization sent chills through everyone who witnessed it. The future of sustainable travel had just been rewritten. But this is only the beginning. The next step is scaling. Entire railway networks must be equipped with RF infrastructure. Governments must invest, private companies must collaborate, and global industries must adapt. Challenges remain. Can the RF system be built affordably at scale? Can it be protected from cyber threats or sabotage? Can the technology be standardized internationally? These are questions for tomorrow. But today, we celebrate a victory for humanity. We've proven that infinite range trains are possible. And if trains can run forever, what about trucks, ships, even aircraft? The RF breakthrough could spill into every corner of transportation. Imagine highways with embedded RF coils charging cars and trucks as they drive. Imagine cargo ships powered wirelessly across oceans. Imagine planes recharged midair by RF beams. The dream of a fossil-free world feels closer than ever. The Africa RF train test is not just a milestone in rail technology. It's a beacon of what's possible when innovation, ambition, and sustainability align. And as the world watches, one thing is clear. The age of limited range is over. The age of infinite travel has begun. This is Africa's gift to the world, and the journey has only just started.